Before moving forward, I'll just quickly share my screen and share it. So this is one of a kind of tensegrity structure over there. So on your right hand side screen, the one that you are seeing, this is a tensegrity structure form. So what happens is, let me just show you. So there is one cable which is connecting like this. These are two cables. Okay. So these two cables are connecting like this. And there is one cable exactly at the center like this. Okay, connecting both of them together like this. So red and green over there. So let me just highlight green with some different colors so that it is more visible. So let's go with red and blue. Okay. So you can see, so tensegrity structure is basically a self, a structure that can attain self equilibrium. So if one of the component or one of the cable is in tension, the other cable will be in compression. So it is capable of achieving self equilibrium. This red is in compression. Okay, like if this red, images, I am compressing these. Okay, I am compressing these like this. Then this immediately the blue one comes in tension. Okay, like it will basically go like this. Okay, so this is your tensegrity structure. Why this is important? Because you can see from the images also, like it is widely used in many of the construction sites like this. So various cell balancing structures can be made using this tensegrity structure. Okay, so what our goal is, so you can see this is a tensegrity structure over there. So what our goal is to find out whether the structure that we are going to make, okay, so whether it is going to withstand or not. So whether can we say that this is a tensegrity structure or not. For that, this is SolidWorks 2023, and I would simply show you, since this is not a CAD class, so I'll simply show you that what has been done. So over here you can see these. This is the dimension. So it's a 150 by 200 mm. So it is simply a boss extruded part over there. Next is we have made a center part like this, and this is third part, and have made some holes over there, so you can see, to put the spring over there. So mirroring that same feature over there as well, and a center hole like this. Okay, so this is a simple one-sided part. So we have made one body. Next is we have flipped the model. So you can see we have got something like this. Okay. This is total of two bodies. So one body and second body. Okay. So these are two bodies over there, solid bodies. And you can see like this, we are achieving this. Just focus on the center hole. So center hole is exactly aligning with this center hole. So these two are concentric. The highlighted one, these two are concentric, like it is sharing the same center point. Okay, so have made this. From the top view also you can see, so these holes are also aligned, like all the holes are aligned to each other, and you can see, so that we can input our load condition over there. Okay, now without further ado, let's jump right into the ANSYS. So this is your ANSYS workbench. Okay, on the left hand side, you can see there are different modules. So we'll be choosing the static structural module for this particular scenario. So what I'll be doing, I'll be simply opening the static structure like this, dragging and dropping it. And you can see this is the condition. So engineering data is green tick, rest everything is in question mark. So what engineering data is, it's basically the properties of all the elements, like the physical properties, whether it's silver, gold, aluminum, steel, copper, and maybe some of the composites like aluminum alloy, copper alloy, bronze alloy. So all these physical properties are pre-stored in the library of ANSYS. So this is your engineering data. Next is what we are going to do. We are going to import our geometry. So right click, go to import geometry, and here I am going to simply import the model. So you can see tensegrity model is there. So I'm simply going to import that. So now the model is imported and it is also green tick. Next thing is we are going to open the setup file. So once the setup file will open, which is this second window, in this particular window, we are going to do our ANSYS. Okay, so as you can see, these are two bodies over here, body 1 and body 2. So these are two bodies over there. And this is our model, the one I have showed you. I have imported that inside ANSYS now. Okay, so this is our model now. So what next we are going to do? Basically, we have to apply some of the boundary conditions to it. Okay, so first of all, we have to apply the connections. For the connections, you can see I'm going to apply the body to body, and instead of cable, I'm going to apply the spring. So in the connections, I'm going to apply the spring connection so that it is easily visible if a spring is in tension or a spring is in compression. Okay, so I'm going to start off with the spring. So I've selected the spring. So first thing it is asking me for the like the scope. So what scope actually is, it's basically the body on which you want to put that spring. So here I'm simply going to select this point over here, which is the center point. So you can see it is a spring is there now. Okay, connecting to that point. Next is up to what. So here I'm going to select this second point up to here I want. Apply. So now you can see this is the condition. Okay, so I have simply applied like a connection of spring connection between these two slots. Next is we have to apply the stiffness. So basically I'm going with a stiffness of 4 Newton per millimeter, sorry. So 4 Newton per millimeter. That is going to be my first connection. Okay, so this is my connection 1. Next is what I'm going to do. I'm going to do the same on the other side. So body to body coming to spring. In the scope, I am going to select again the top, the internal face of this, apply. So now we are having one spring which is attached to that. That is next is like up to where. So next in this scope section, I'm going to select this, apply. So up till here, this is going to be my second spring. Longitudinal stiffness, I'm going with the same, which is 4 Newton per millimeter. So now you can see these two springs are there. I have to add one spring also so that it will be a connection for the center. So what I'm going to do, I'm simply going to add another spring. So body to body, coming to connection and choosing the spring. Scope, I'm going to select this point over there, which is my central, face of the slot. And next, I have to select the other scope. So this scope is going to be the point over here. Apply. So now you can see there is a small spring over there. All right. So there is a small spring as well now. And for the stiffness, let me just go with 4 Newton per millimeter. So this is my condition right now. Okay. So as you can see, like as you can imagine over here as well, that if I move this top face downwards, okay, if I move this top face downwards, this spring and this spring are going to be in compression, right? So these two springs will be in compression. But if we talk about this spring, which is at the center, this will experience tension. Okay, so this spring will be extended and these two springs will be compressed. So that is what we want to see, that whether this is happening or not. If this is happening, then only we can see that yes, exactly, we can do it. Okay. So next is moving forward. So next is what we are going to do. We are simply going to apply the force and load over there. So what exactly we are going to do now? We create the mesh. So for the mesh, what we are going to do? We can simply go with the basic one, which is update. So I'm going to update the mesh over there. So as you can see, this is a default mesh. So default mesh is being updated. So let's get back. So our mesh is created. So I am going with a default mesh over there. So as you can see, the mesh is being created on the body, on both the bodies. Next is we are going to apply the boundary condition. So for the boundary condition, what we are going to do, simply right click, go to insert, and you can see these are all the boundary conditions that we can apply. First of all, I'm going with the standard earth gravity. So I have applied that. Now here what you can see, the gravity direction is in the minus z axis. So it is facing in that particular position. So you can check the direction of this from this triad. So you can see from here minus z axis it is going. So what we are going to do, we are going to change the direction. So on the left hand side of your screen, you can see there is a table from which I can change the direction. So I'm going to select minus y. Now the direction of Earth's gravity is in downwards. That is how it has to be. Next is what we are going to do. We are going to apply the fixed support. So we want a base support for it. So we are going to apply fixed support. And at the bottom face, which is this face, I am applying my fixed support. So you can see this blue area or the blue region over there is my fixed support. Next is what we are going to do. On the top, which means on this face, we are going to apply the displacement. Okay. We want this particular body over here, which is this body, to move downwards, which is in minus y direction. As you can see from here, this will be in minus y direction. So what we are going to do, we are going to apply a displacement in that particular direction. So right click, insert, and here you get to see the displacement. So you can see there is this displacement. So I'm simply going to apply displacement. It is asking me for the geometry. So this is my geometry on which I want to apply the displacement. So I've selected that particular face over there. Now you can see there are components. So X, Y, and Z components. So in X axis, it is free. In Y axis, it is also free. So let me just give 0 over there because I don't want any, in the X and Y axis. For this, I want to apply in a tabular data. So what I'll be doing, I'm going to apply the direction or the displacement in minus y axis. So what I have did, for x component, I have put it 0 because I don't want any displacement in that direction. So for x, which is this red arrow you can see, x I have made it 0. For z also, which is in blue color, I have made it 0. And for the y axis, which is in green, I want to apply that in the minus y direction. So what I'm going to do, basically I'm going to input that content in the tabular data. First of all, we can see over here there are number of steps. So only 2 steps are there right now. In the analysis setting, I'm also going to increase the number of steps to 30. So I've increased those number of steps to 30. So that in the displacement also you can see there are 30 number of steps now. Actually 31 because it starts from 0. So you can see these 30 number of steps over there. So that's how you get the steps. Okay. So I have simply applied those number of steps over there. Now we are going into to apply the displacement. So as you can see, it is in minus y direction, which means I have to apply a minus sign in front of it. So what I'm going to do, for the step 1, it is at 0. Okay. For the step 2, it is at, for the step 1, it is at 1. For the step 2, it is at 0. Coming down, for the step number 31, I'm simply applying minus 20. And in between that, all these will be filled automatically. So you can see in the minus y direction I want. So starting from 1, then comes 0, then minus 0.6, minus 1.3, minus 2.069, then 2.7. It is going till minus 20. So you can see there is a linear graph going down for the y-axis. Okay. So this is the quantity which I have applied for the y-axis. So this face will be moving downwards 20 mm in the y direction. Okay. So this is the displacement that I have applied over there. Next is coming to the solution. So what we are interested to see? We are interested to see the deformation. So here, insert, go to deformation, and I'm selecting the total deformation. So total deformation, I want to see whether it is like how much it is going down and everything. So this is our step. So right now we have did our pre-processing steps of ANSYS. Next is we are simply going to click on solve so that the analysis will solve this for the particular solution that we want, which is as the result we want the total deformation. So you can see everything on the left hand side tree is green tick, but there is a yellow icon over there. Same yellow icon you can see on the top which says solve. So which means you just simply click on solve and your analysis will be start to solve for this particular problem. Okay, so now you can see this is for the total deformation over there. Now here I want to show you the graph. So here we have applied the displacement and you can see that these two springs over there. So let me just show you a little bit more closer to it. So you can see, let me just mark these two springs for you, spring number 1 and spring number 2. So these two springs, as you can see, are in compression. Whether this third spring, which is at the middle, is experiencing tension. So what is happening exactly? It is trying to maintain self-equilibrium. If a structure can maintain a self-equilibrium, which means it can be stable on itself. Okay. So what is happening over here? So if you apply a load, let's say if I'm applying a load on the top, on this top surface, I'm putting something. So anything if I'm putting on that, it will try to maintain the self-equilibrium, like it will not break. Okay. So only one thing that can break if the middle spring tension gets highlighted over there. So if middle spring is going apart from it, then that may be the condition that it will break. Apart from that, this structure will maintain the self-equilibrium. So this is exactly what tensegrity structure is. Okay. So as you can see from here, these two springs are getting compressed. Okay. But this spring is facing tension over there. So you can see this spring is getting extended and these two springs are getting compressed. Okay. So this is how you can say that this structure will survive on its own because it is trying to maintain the self-equilibrium. So this is your tensegrity structure ANSYS, or you can say analysis over there. So this is how you can make such structures like with this help of springs. You can say these as a self-balancing structures over there. So these are known as your tensegrity structures.